Dave Merriman sent this tape describing his new watertight cylinder.
As recently as 5 years ago, it was almost impossible to make a radio-controlled submarine work at 196 scale unless it was one of the monsters such as the Trenton or perhaps the Ohio-class submarines. However, with the advent of the control devices developed by outfits like Subtech and High-Tech, we're able to fit in a reasonably small package all the control elements needed into a watertight cylinder, which D&E Miniatures has developed for people who want to operate fully capable small model submarines. To demonstrate the utility of the watertight cylinder, we've built this model of a 196 Alpha class provided by Paul Doman, a subcommittee member. Model works quite well, is fully capable in that it has 4 channels of control, one for propulsion, one for rudder, one for stern plane, and the 4th for the ballast system. All items that need to be maintained in a water or in a dry environment are stored within a watertight cylinder designed and distributed by D&E Miniatures. We'll go ahead and disassemble this model to reveal the inner workings. The model is assembled in the manner that Greg Sharp and Dan Catcher have advocated, and that the upper and lower hull halves have been divided in such a manner as to require only one fastener to hold the whole assembly together. Now, keep in mind that the model submarine can be just about any subject, providing it has the internal volume to house the watertight cylinder, has the traditional control surfaces. The watertight cylinder is broken down into 3 spaces. The forward space, the dry space, houses the battery and speed controller. The center space, which is floatable, is the ballast tank, which of course is the point about which the model rotates in roll, pitch, and yaw. The after section, another watertight area, is the control and propulsion area, attached to which is the motor cup, the space which contains the control equipment. The watertight cylinder itself is retained, that is mounted within the hull through simple rubber bands, which affords a great deal of flexibility as far as positioning, and certainly lets you access the machine with very little trouble. The only mechanical connections between the watertight cylinder and the hull are the 2 control outputs from the servos, stern plane, and rudder. And of course there's a drive shaft employing the Dumas couplers for the propeller. All that's required is to break the connections. In this case it's done with the connections are made up with the steel balls and nylon cups. Once that's done, it's a simple matter of just slipping out the entire unit. Now the virtue, as you can see, is you can quickly access the watertight unit for adjustment or repair, or, as we suggest, to install into another hull. And this of course means that you only make your purchase of the radio system one time. You install it within the cylinder, and that goes into, if you will, any number of a fleet of submarines you may have at home. The model itself is a traditional fiberglass constructed hull, and that about rounds it out. The only thing you have to do special with the hull is provide foundations, just semicircular rings cut out of plywood in this case, which are then bonded within the hull and waterproofed with resin. Alright, we have the watertight cylinder pulled from the model submarine. In this condition it's easily accessed, and we can perform any maintenance or battery change needed. It's operational right now. The propulsion, ballast, rudder, and bow planes are active, as you can see here. The regular maintenance underway when it's installed in the model is nothing more than charging using a propel can the onboard bottle through this charging fitting. The watertight cylinder, as I explained before, can be quickly unshipped from the model and transferred to another or maintenance performed. Typically you start by turning the unit off. As you can see, it's still on, it's responding to its angle keeper. I don't like to use the switch on the speed controller. I simply access the forward bulkhead and disconnect the speed controller from the battery. Here's your typical 12 to 1500 milliamp hour battery and the recommended Traxxas speed controller. Those are the items which are housed in the forward tri-space. Continuing with the maintenance is simply pulling out the after bulkhead, the motor cup, and disconnecting, if you wish, for storage, the connections to the ballast tank servo and the connections for the speed controller. What we have here is all the goodies which makes the submarine controllable and that powered it in this one package, which, as you can see, was accessed in a matter of seconds. If you want to further disassemble, you can take off these mounting rails from this motor bulkhead. You access the motor and the gear train, which can be removed by unscrewing these thumb nuts here. So this is the condition that the watertight cylinder is stored, and as you can see, it's a very simplistic arrangement with the J-type connectors which you get with most radio today. You make up those connections, you hook up the motor, and you're good to go. The only considerations you as an RC submariner have to be aware of is that your O-rings are maintained in a clean and well lubricated state. Other than that, it's a very, very simple item to maintain and to install and to use. The ballast tank perhaps has the most unique features in that we have an onboard bottle which is charged with propel liquid. And of course we have this gas saver device, which is, if you will, akin to a bathroom toilet float, though in reverse. When this float is immersed in water, it engages and enables the blow system to operate. When the tank is dry, on the other hand, the float disengages the linkage and you cannot blow. The consequence is you don't waste gas. It's only employed when you have a partially or fully flooded ballast tank. So the gas saver will give you in excess of 30% more blows from the available gas in the bottle than you would if you were just doing it hit and miss and hoping for the best. So it's a positive means of controlling the flow of ballast tank gas. The WTC-3 motor bulkhead here contains skip ACs, that's Subtex 1/8 inch servo watertight seals, and they give very good service. You just put them in there and you can forget them pretty much. Just put some light machine oil on them occasionally. I also employ the 3/16 inch drive shaft put out by High Tech for the propulsion output. The bulkhead itself is cast from polyurethane resin. It's got an average wall thickness of 1/8 inch. It's very robust, and as far as withstanding the hydrostatic pressure, there's no question that this thing is good to 100 foot. We test them in shop before deliveries to 2 atmospheres, about 30 foot. So you're getting a unit that's going to work way in excess of any depth you should be at. On the after face of the motor bulkhead, you have the 2 retaining thumb nuts used to secure the drivetrain, which includes a 3-to-1 gear reduction unit and the motor. Removing these after you've removed the rail thumb nuts permits removal of the entire propulsion unit. The coupler here is your standard Dumas coupler, which we use with a dog bone for the intermediate drive shaft. The O-ring seal here is what affects the watertight seal between the unit, the motor cup and the Lexane tube. The typical installation, though I could have used standard size here, I have some mini servos, one for the operating the rudder, the other one through the angle keeper operates the stern plane. Here we have the old style APC-1 angle keeper, which is given very reliable and good duty, and your typical Futaba receiver and a Subtech fail-safe device. There's plenty of room in the WTC-3 for the equipment, and there's no significant bunching of cables or wire runs. As you can see, the ballast tank bulkhead has mounted within it a servo, and that's the ballast system servo. It has to be hooked up, of course, to the output from the failsafe through a standard J-type connector. Here we have a Tamiya connector which makes up to the motor. This leads from the speed controller. The electrical conduits through the ballast tank, the conduit itself is a piece of brass tube, and it's outfitted with O-rings itself, which provides a watertight seal between the conduit tube and the two dry spaces, and it provides a passage for the cables. And as I said before, we have the speed controller in the forward section, and it shares it with the battery. And what makes watertight the forward end of the Lexane tube is a cast resin bulkhead. A bleed equalization valve, a Schrader valve, is provided so that when the units are attached to the tube, the slight overpressure can be vented off, and this precludes any chance of the bulkheads coming out as things warm up within the unit. The watertight system here, the WTC-3, is available from D&E Miniatures. We have literature if you want further explanation and photos of the product. We're at 835 Holly Hedge Avenue, Virginia Beach, Virginia. Address will follow. Getting ready to operate this little 196 Alpha. I got the watertight cylinder here. The only thing you got to do is bang up the onboard bottle with Propel, service the ballast system, and hook it up, which is nothing more than making up the dog bone and coupler to the drive shaft, hooking up the rubber bands to secure the cylinder within the hull, that's all we need to hold it in there. The watertight cylinder sits against a little backstop inside the hull, ensuring that its distance is always the same, so that when I hook up these control surfaces here to the nylon connectors, I always have the same centers for the control surfaces. Transmitter, hook up the switch, which I've already done, and do a functions test. The ballast system, I checked that the vent valve opens freely, and blow doesn't happen because we have a dry tank. But if I place the transmitter trim all the way to the blow condition and then command a blow, listen. That's the motor. There, you can hear the blow. Okay. So all that's left to do is to button up the hull, which just takes a moment. Secure the one screw back here, which holds the hull halves together. We're good to go. Let's check it out. First off, check that it's at normal surface trim. Then we command the vent. Right now the air is escaping out of the ballast tank. Yeah, the boat's in a slightly negative condition. Probably used a bit of foam up front here. So we'll go ahead and blow to the surface. There we are. And of course the gas saver prevents expelling any additional gas. Gene's got these tubes lined up just to demonstrate that you PT boat fans perhaps can shoot torpedoes as well. Just imagine this is the deck of a PT boat. You got one of these gas charged torpedoes in the tube, and all you have to do is pull the lanyard and you watch how this thing works. Down goes another Japanese freighter.
Okay, we're shooting. Go ahead, fire.
Next one's ready.
We're rolling. Shoot.
Ooh. Another again.
Hang on. One more.
Here we go. Okay, another.